Hey guys, today I'm going to do a capture of some beacons because I know you like beacons, but I'm going to pay particular attention to the beacon interval, and we're just going to have a look at that in a couple of different scenarios. Okay, to do this, I've got just a run-of-the-mill TP-Link access point router thing here, and it's running in 2.4 gig because I want to also capture some other networks in the neighborhood. I've got the MacBook here doing the packet capture, so it's not joined up, it's just there doing the packet captures. And this Linux box over here is a client to the access point. And in the background I've just got the Spectrum display, which may show some stuff, but I'm not paying too much attention to that, it's just there running. So what I'm going to do now is do a quick packet capture. Just at the moment there's no traffic going through my network anyway, and it'll pick up some stuff from the neighbors. I'm just on channel 1 here, so I'll just run that and save what I've got there. Okay, I've just saved that first capture when nothing was really happening. Now what I'm going to do is start a video stream playing on here. Now this is just from one of my security cameras I've just got coming through, okay, via this access point on channel 1. And you can see on the RF there, channel 1's getting smashed a bit. So I'm going to do a packet capture again while that's got some traffic going through there. And as I said, what I'm going to do is look at the interval between the beacons and see how that's affected when there's a lot of traffic around. So that should be enough. I'll just stop the capture now. Okay, so I've done those captures with the MacBook, but I'll load them up into Linux and we'll have a look through the beacons in there. Okay, I've just opened up the first packet capture, the one when the laptop wasn't doing much, and we'll just have a look at what beacons are around. So first of all, when I open the packet capture, we see, a lot of all sorts of stuff. These things here with the black through them, that's because it's a corrupt frame. You can see the FCS didn't add up. That's most probably because it's just sort of half got the beacon from a far off neighbor, so it's not the best. Anyway, we want to look for my beacons. So the one is called SSID CWNE88. Okay, so the first thing I'll do is just filter for that SSID. So you can see the SSID there. Right click, apply as filter. There it is. So that's beacons and other things, but I don't have anything else in this capture, so it's the only thing that's showing the SSID are the beacons. Now beacons have a time interval between them, and even though most routers in their config say 100 milliseconds, it's actually 102.4 milliseconds. Okay, that's a nice computer number there, 1024. It's 102.4 milliseconds, ideally. So if we have a look here, just skip into the middle of it somewhere, you can see a beacon frame, you see the time. Now, you could do it in your head, go 0.5518 to 6543, but there's an easier way. In Wireshark, the first line down here has a whole bunch of things to do with the time. And one here is the time delta from the previously displayed frame. Okay, now I've got a display filter, so this is the displayed frames. If I just right click on that and apply that as a column, we now get a new column here. So it's a lot easier to see the time delta between this and the previous frame. So you can see from that, the most part, they're roughly 0.1024, but they're not all exactly 1024. Okay, now any wireless frame, whether it's a beacon or data frame or whatever, before it transmits, it has to make sure, as best it can, that there's nothing else already transmitting, okay? So if it goes to transmit, in this case a beacon, and it detects there's energy in the channel and it can't transmit, then it can't transmit, it has to wait. And it'll be a bit longer than the 0.1024 seconds. So as you can see, 10247, 10242, and some are less. The reason is, it has its interval when it wants to transmit. So let's say it's now. And then 0.1024 after that, ideally it would like to transmit the next beacon. But if it can't, because something was transmitting, it has to be delayed a bit. So let's say it goes to 0.1025. The next beacon, it will try to bring back to where it should have been had it kept going at 0.1024. Okay, so that's why some of them are a bit less than 0.1024. Okay, but now that I've applied this as a column, you can just click that column and, like most programs, just sort by the column. So now, forget the first couple, you can see the lowest interval is 0.1021 going right up to 0.1028. Now that's a bit of a problem because it's a lot longer than it should be. And beacons are used for timing of the network, okay? The clients use them for, it controls the network. It doesn't just transmit an SSID, okay? It's used for other things as well. And the primary one is timing. So if they get too far out, it can be a problem. Okay, now that was with no real activity going on the laptop. So I'm going to show one now, the other one that I took when I had the video stream going through. Okay, this time I got the capture open, but I also had a client on. So even though I'm looking for the SSID of CWNE88, we've got other packets in here that also contain the SSID, because remember, it's not just the beacon that has the SSID, but we're only interested in beacons at the moment. So what I'm going to do is just filter that by the SSID and for beacons, the type of beacons, which is WLAN frame controller type subtype equals 8, because I know that's beacons. Okay, so now I'm looking at just beacons and just the ones that have the SSID of CWNE88. So now, looking at all my beacons when I had the video stream going. So now I'll just sort them by the time of the previous displayed frame again and see what we've got. Now you can see if I start off at the smallest, minus the first couple, we're again down to 1022, which means in itself, straight away you know that it must have missed somewhere along the way at their planned interval, such that the next one had to be brought, you know, a less interval between those two. So going through 102.1024 is the optimal one, but there's a lot more that are above that. Okay, going right up, and then we've got this 2048, so that's double. So straight away you know it's missed a beacon, and that's bad. So if I now just put them without the filter, so we see everything, and go back in time order, which we already are, what we see is we're not in time order. There we are. What we can see is what happened before that beacon at all on the network. So I'm unfiltered now. So there's the beacon that was late, which you can't tell from that really. You can't tell automatically when the previous beacon was. But with a bit of fancy filtering, you can soon find these things. It's just a bit of Wireshark foo there. Okay. But you can see there was a lot going on before it. There was a lot of, look at this, request to send, clear to send data, block act, bang, bang. And somewhere in that, the beacon got lost. It couldn't make it for whatever reason, and I would have captured it because it was right next to it. So if a beacon can't get sent out on time, it can become a problem. Now this can be a real problem when there's a lot of beacons in the air, okay, hidden or not, doesn't matter. It's using up RF space, and especially if they're using low bit rates, which I know this is. If you look at, if I just look at one of these beacons, you can see that they use right down to 1 megasecond, which is bad. And this particular one, if we go to the radio tap header, which I've shown in a video how to do, you can see that it's using 1 megasecond. So that's pretty bad, which I expect from a home type of device. But that's how beacons work, okay? The main thing is, even though it says 100 milliseconds in most config, it's 102.4 milliseconds. And ideally, it would like to transmit them every 102.4 milliseconds. But if one's late, the next one will still try to be where its original one is, okay? 0.2048 from the previous one, to try and keep them where they should be. But anyway, that's just a brief overview of the beacon interval, and in coming videos I'll probably dive more into beacons, or maybe some Wireshark, or a bit of both. Just take it as it comes along, and I'll see you next time with something new.